Hello, and welcome to the Midwest Technical Inspections virtual seminars. Today, we are going to be discussing commercial cooking exposures, and so we will be following along with our restaurant and tavern writer. So, the restaurant and tavern writer, or the RETA, is a form that we have created for filling out questions about commercial cooking exposures. So when do you complete the RETA? Well, sometimes the RETA will actually be ordered on the report, and so obviously you will just fill it out as it's ordered. But it is a writer, so it's meant to go along with another type of report, another line of coverage. It is a supplemental form. So sometimes you're going to develop that there's grease vapor producing cooking, but maybe the underwriter didn't know that there was, or just didn't know how to order the RETA or something like that. And so anytime you develop that grease vapor producing cooking, then you're going to go ahead and add the RETA and complete that RETA exposure. The exception to that would be obviously if the idiosyncrasies tell you not to complete the RETA, or for the SRS form. The SRS form has its own cooking section built into the form. And so there's no reason to add the RETA and duplicate those efforts. But otherwise, if you develop that there is grease vapor producing cooking, so that means that there's deep fat fryer or some grilling that's produced, meat that's going to be producing a grease vapor, or stir frying or broiling, something like that, that it's going to be releasing the vapor into the air and having those grease vapors potentially settle on the surfaces around it or be an ignition point, then we need to add the RETA and complete that RETA form. If all they're doing is baking or residential cooking where the amount of grease being produced is very minimal, if any, well, then you don't need to complete that RETA form. And if you're filling out one of our standardized forms like the multi-peril survey, when you get to the question that asks you about the cooking exposure, you'll see on there that there's a in parentheses it'll say commercial grease vapor producing cooking, and it'll say in parentheses to add and complete the RETA. So you should be prompted to go ahead and do that. So when we're looking at the commercial cooking, the governing authority or the rules that we follow are the NFPA 96. So NFPA 96 is the standards or commercial kitchen standards, and that is the authority that we will use when we're referencing recommendations and things of that nature. So that's the standard that we're going to be looking at. Now, the UL 300 standard is for the fire suppression system in those commercial kitchens. And the UL 300 standard took place about 1994 and is up through the current date. So anything that is after 1994 then needs to be updated to the UL 300 standard. There was a time period there for a while where they were allowing for the grandfather clause, where if you had a system that was installed before 1994 and properly maintained, then they would allow it to be the non-UL 300 standard. But it has been long enough now that there's no reason to have anything other than a UL 300 standard system inside the kitchen. So all kitchens, all commercial grease vapor producing kitchens should be that UL 300 standard and follow NFPA 96. So when we go through the form, the first section, just like all of our other forms, kind of is a summary of what's going on, what type of restaurant is this? Is it a bar? Is it a social club? What kind of activities go on there? But then we have to get into a little bit of some of the finer details. So we look at things like the seating capacity and the maximum occupancy. These are very similar items, but they are slightly different in the fact that the seating capacity is strictly looking at how many people can be seated at any one time. So looking around, give us an estimate on how many chairs there are at the tables or booths or at the counter, how many people can actually be seated at any one time. Now, the maximum occupancy, that's something that's going to be designated by the fire department. And there should be a posting somewhere in the building that tells you what that maximum occupancy is. Most of the restaurants that you go to are going to have it posted right there at the front entry by like the hostess counter or the hostess desk. And it'll be posted on the wall, and it'll tell you what the maximum occupancy is. And so that's going to not only include how many people can be seated, but also standing. So people that are working there, like the waiters and waitresses, anybody that might be milling about or just in the building that is not currently seated. So it's going to be a higher number than what you see for the seating capacity. We also want to kind of give an idea of how heavy the cooking is, how much grease vapor is being produced. So we're going to have a three-tier system for rating the cooking volume. Now, this is going to be a subjective answer where you and I can look at this and both give two different answers, but both be correct, because there's no like real fine definitive answer here. So it's going to be somewhat subjective every time you look at it. But we'll give you some kind of guidelines here. So a light is going to be something that's really serving limited amount of food, or the types of cooking that they're doing is going to be low volume for grease production. So maybe a lot of baking or things like that, where there's going to be smaller amounts of grease vapor. So it's typically going to be something that has a limited menu or a limited time frame. So maybe they only cook a couple days a week, or maybe they only cook breakfast or maybe breakfast and lunch. Dinner tends to be the heavier grease production. So that's if we don't see any of that dinner, then it's a good chance that it's going to be in that light cooking volume category. Medium then is going to be most of your family style restaurants. Anything that's serving foods that are deep fried, you're going to be at least the medium in that cooking volume. So if you have that deep fryer, or if you have a wok, those are the two heaviest grease producing equipment. And so those are going to fall into at least that medium, depending on how much they use those pieces of equipment. And then heavy is where you're going to get into like the fast food restaurants or the Chinese restaurants, or maybe like a hot wings restaurant where they have multiple fryers and they're just producing a lot of volume of grease vapor, and they're cooking 24/7. So they have breakfast, lunch, dinner, and long hours of cooking exposure. So that's where we're going to get into those heavy cooking volumes. Next, we're going to go through and look at the different pieces of equipment that you might run into in a commercial kitchen. The great thing about kitchens is that once you've walked into one, you've pretty much seen most of them. They are all very similar. They're using the same types of equipment, but we want to make sure that we're getting the proper terminology for the equipment so that we can know which boxes to check on the form. So we're going to go through that list of cooking equipment now and show you some examples and talk about some of the higher risk pieces of equipment and the exposures you should be looking at with those pieces of equipment. So Broasters is a way of making a deep fried chicken under pressure. So it's going to be one of these types of machines here that it's a deep fryer, but they're frying it under pressure. So the grease gets really embedded into the chicken and makes it extra moist and tasty. However, because it is a pressurized cooking operation, that grease is actually going to be contained. So it's going to be held in by the lid that's closed over and sealed shut on it. So you're not going to have very much grease vapor coming off of the broaster. So it's going to be a relatively low exposure. It still does need to be underneath the hood and duct system, especially like when you open it up to get the chicken out. Then it's going to have some grease vapor released. So we still want it under the hood and duct, but it's going to be a low exposure, much lower than the standard deep fat fryers. The broiler, this is going to be a way of cooking meats where you put the meat in close proximity to a flame and you cook it at a high temperature, and it gives you a nice crisp seal on the outside of it. So most of the broilers that we look at are going to be these types of boxes here where you see there's like a tray that pulls out, and you see that they put the meat in there, and then the flame is actually inside here, and so that it'll be in close proximity there. One thing that you want to make sure that you're paying attention to is the AES on the broiler. You'll see that the piping comes down, and it actually points right to that opening where the potential flames might be shooting out. If they catch grease on fire, then this is where that grease fire is going to actually be. So we want to make sure that the AES nozzle is actually pointing where that fire exposure is going to be. You're not going to do much good just pouring the chemical onto the metal box around the fire. You want to go to that actual point of operation. You will notice that it does produce a lot of grease vapor because it's a high heat. The fats on those meats are going to be vaporizing and releasing up into the air around it. So the filters above the broiler are oftentimes dirtier than the rest of the filters, just because there's a lot of grease vapor coming up off of that. Charcoal and wood grills, when we see these types of operations, the biggest concern for them is just how are they disposing of the ashes afterwards? Do they have a designated metal can that they're putting the ashes in, or are they just throwing them into the standard garbage? Are they putting them in a paper bag or a plastic can, or what are they doing with those ashes? Just because they're ashes doesn't mean that they're actually cold or that they won't reignite or catch fire. So we want to make sure that they're disposing of those properly and have some sort of system in place. We also want to look at where is this operation being done, because there is going to be some toxins and some smoke that's being released from this type of cooking. So if it is inside, we want to make sure that it's being properly ventilated. If it's outside, then you have much more freedom over where it can be done, as far as you have the airflow that's going to be carrying that smoke away. But inside, we want to make sure that there's proper ventilation, things like this chimney here that's going to take it up and out of the structure. Deep fryers are one of the biggest volume producers for grease vapor. So we really want to make sure that we're paying close attention to these and checking them for adequacy. So with the grease fat fryers, one of the things that we need to look for is there a temperature limiting thermostat on it. So almost everything manufactured now is going to have that thermostat built in. But if you open up the front door on the deep fat fryer here, you should see that thermostat down there. That's going to limit how hot that grease can get, because grease, once it catches fire, is going to burn and burn and burn until you really have some kind of extra force to put it out. It's going to burn for a long time, and there's a lot of volume of fuel inside of that deep fryer. So we really want to make sure that it doesn't ever get hot enough to self-combust. And then secondly, we need to make sure that there's no other ignition sources, anything else that's going to catch that of flammable liquid on fire. So we want to look at how it's related, or where it is in relation to other pieces of equipment, and if there's any kind of open flame or ignition source on that other equipment. So like this one here, we see that it's a griddle. There's no actually exposed open flame here, so it's okay to be right next to it. If this had an open flame exposure, then we would want to see a clearance of 16 inches or a 8-inch high stainless steel barrier between them to give that separation between the grease vapor that's being produced off of the deep fryer and that open flame, so that we don't have anything to ignite it or set it on fire. So those are the two biggest concerns that we have with the deep fat fryer. Enclosed pressure cookers, these are relatively safe as far as the fact that they don't really produce a grease vapor, but they do produce a high pressure. So we want to make sure that they have the proper securement of those pressure cookers. So you can see this one's got the bar that goes across the lid here and then cranks it down and secures it in place, so that as that pressure builds up inside, it's not going to explode and blow that off of the piece of equipment and damage things around it. But otherwise, it's really contained, and any grease vapors that are being produced are being contained within that system. So it's a relatively low risk piece of equipment. Griddles, these are a very common type of equipment that we see in a lot of commercial kitchens. They're very versatile. It's just a flat piece of metal with an internal heat source, so they can cook all kinds of things on it. But you'll notice that there's nowhere for the grease to go except for up into the atmosphere or scraped into a tray afterwards. So they do tend to produce a lot of grease vapors, depending on what it is that they're cooking on those griddles. So we definitely want to see these underneath a hood and duct system with the AES in place. But the good thing is that the heat source is internalized, so they don't have that open flame. So we're not worried about catching things around it on fire. Microwaves are a pretty simple piece of equipment. There's not really any grease production being made off of them. The biggest concerns we have with them is going to be things like putting metal inside them, having electrical fires and things of that nature. But generally, if we see the microwave, that's a low risk. It does not need to be underneath the hood duct system. So it's a low risk exposure for us. Commercial ovens, they may be for pizzas, they may be for making breads or pastries or anything like that. But when you have an oven, the grease vapor production is very little, if any. So we don't have to have them underneath of a hood and duct system, and you don't need to have the AES system on them. This one you can see does have the hood over the top of it, and I think that is mostly just for capturing the heat so that it doesn't make it so hot inside of this kitchen. So it's just exhausting that heat outside to keep the temperature inside the kitchen at a better temperature. But it is not required to have the true baffle plates and exhaust system to exhaust the grease vapors. We do see a lot of domestic equipment inside of commercial kitchens. So if you see that domestic oven range in there, that is fine. It really then we have to look at how they're utilizing those domestic ovens or ranges. Are they using them in the way that they were intended to be used for the types of cooking that you would see typically in a domestic use? Or are they using it for higher grease production and heavier quantities of cooking, where now it's being really treated as if it was a commercial piece of equipment? So if they're using it for those high volumes and the heavy grease production, then we still need to have that hood and duct system over the top of it with the AES. But if they're using it for the actual domestic style of cooking that it was designed for, then it would not necessarily need to have that hood and duct system in the AES system. If you look at most of your ranges or stoves at home, they do have a small fan system over it. It doesn't have the grease collection like you would in a commercial system, but it does have an exhaust system for any kind of smoke or buildup that gets created from that cooking. And so that's what you might see oftentimes with this commercial use of the domestic equipment as well. It's never a bad thing to have a hood and duct system over the top of it, but it's not required if they're truly using it for domestic purposes. But as soon as they upgrade to that more commercial style of range, like this one here, where they have multiple burners and they're using it for a higher volume of cooking, well, then they definitely need to have that hood and duct system over the top of it with the proper grease trapping baffle filters and then the AES system to protect from any fires. So as soon as you bump up from that domestic to that commercial, now we don't really even care about how much volume they're cooking. Is the fact that it's a commercial range, we need to have the commercial protection. With rotisseries and spits, these are usually ways of cooking meats in a very slow, long process at a low temperature. So the greases and fats on the meat typically will drip off rather than vaporize because the temperatures are so much lower. So we don't necessarily need to see these underneath the hood and duct system. It's never a bad idea to put it under there, but it doesn't have to be under the hood and duct system because there's not really any grease vapor being produced. It's all dripping down rather than vaporizing. But we see these sometimes the chicken rotisseries, or we see the gyro spits or something like that, where again it's just a very slow, low temperature cooking process. Smokers. With the smokers, most of the time we see these actually located outside or in a separate structure, kind of away from the main building. But sometimes they will be inside of the main kitchen area or inside the structure. So with those, we're typically really looking at the exhausting of the smoke that's being created, making sure that those fumes are not building up inside of the structure. So making sure they have the proper vent pipes in place and chimneys to get that smoke and exhaust outside of the structure. This one looks like you can see in the haze around it that maybe they're not doing the proper ventilation of this particular piece of equipment. And then depending on how that system is made and set up, you need to check to see how hot that system gets. Most of the time the smokers are a lower temperature where they're not going to have the same risk level of catching things around it on fire. And if it's well insulated, then you may have a zero clearance around it where you can have things pushed right up next to it. But we do want to kind of give it a look to see what the clearances are around it. Now, walks are one of the most dangerous pieces of equipment we have because they have an open flame at the bottom of the wok, and then you have the wok full of oils and greases that are being tossed around and will quite often spill over the edge of the wok and they actually come into contact with that open flame below. So you see a lot of times the fires will flare up and flame up around a wok. And so they tend to be one of the more dangerous ignition points for fire exposure. And so we want to make sure that they have the proper clearance around them. Obviously, we don't have the hood duct over the top of it to exhaust any grease vapors and collect that grease vapor. We want to have the AES system pouring onto that piece of equipment, but we really need to pay attention to the clearances. Now, here we have a deep fat fryer with a vat full of flammable liquid right next to our wok that is going to be having flare-ups and flames shooting up on all sides. So this is an extremely dangerous setting here that we have. We can also see that there's a lot of grease being built up on the surfaces around the equipment. So this is definitely something this is a poor setup of the kitchen. They're not doing the proper cleaning. So there's lots of things for that wok to catch on fire. So we really need to clean this up and get some separation between that grease, the deep fat fryer and the wok, or at least have that barrier between them. The self-contained auto fry units are a relatively newer piece of equipment where we typically see these in the smaller operation, maybe like a bar operation where they have a limited menu of fried goods, and so they don't have the full cooking range. They don't have the full hood and duct system and AES system and everything, but they do want to provide some fried foods, maybe some cheese sticks or something like that. So they would get one of these auto fries where it's a self-contained unit where all of the deep frying is inside of this box. And if you look inside there, you can see they actually have its own little AES system in there. So it's got the little nozzle that's spraying onto the baskets. You have the actuation switch here on the outside. It's being serviced. So it's got all of the commercial cooking protection and it's just contained inside this one box. So this is a safe way of providing that deep fat frying without the full commercial kitchen. Next, we want to look at the exhaust systems. So this is where we're talking about the hood and duct system above the cooking equipment. So this is going to exhaust the excess heat that's built up from the cooking process. This is going to all the steam, all the grease vapors that are going to be rising up off of the cooking process. They're going to go into this hood system, and then they're going to be exhausted to the outside of the building. So as part of that, we need to have some sort of filter in place to catch those grease vapors as they are being drawn up into the hood system. So you have a fan that's kind of sucking the air up and out of the building, but we don't want to just exhaust all that grease out into the atmosphere. So we're trying to catch some of that as it's going out. So the preferred method of filters is something called a baffle filter. So that's the steel filters that you see here, where they're the slotted metal filters that are put into place. And the idea is that as the grease vapors come up here, they're going to catch on that steel, and it's going to then solidify, and it's going to drain down into a collection chamber down here. Now, obviously, if you have a lot of grease, the more grease you have, the more it's going to build up on there. It's going to kind of start to solidify. So we need to make sure that those baffle filters are being cleaned regularly. So you can see on the left-hand side, these are filters that are not being cleaned properly. And that grease vapor is really building up. It's solidifying, it's turning colors. And you can just really see that this is a fire exposure in itself. If you have an ignition source now, all this grease that's on those filters is going to be a potential source of fire. So now you're going to have the fire burning inside of your hood system with the fan oxygenizing it, giving it air and spreading that fire through the hood duct system. So we want to make sure that those filters are being properly cleaned so that we don't see that buildup of grease on top of them. What we don't want to see is a mesh style filter. If you have a hidden system over your range at home, it probably does have that mesh filter up there. That mesh filter is a good way of trapping the greases. So any grease vapor that's produced is going to come up there, it's going to catch in that filter, and it's just going to catch in the mesh and it's going to stay there. It has nowhere to drain away to. Whereas the baffle filters are going to channel it down into a collection chamber and then allow you to remove that collection. The mesh is just going to trap it there and it's going to build it up and build it up. So for commercial cooking, the NFPA 96 says that you cannot use mesh filters. They are not acceptable. So anytime you see those mesh filters in commercial cooking, we are going to be making a recommendation to have those removed. And you can see, both of these examples here are grease covered. They're changing colors. The one on the right is barely going to have any airflow through that because the grease has built up so much. But any mesh filters are not acceptable for NFPA 96 for commercial cooking. And if we see any other types of combustible filters, those obviously are not going to meet the NFPA 96 standards either. So sometimes you see people will, temporarily they'll put up paper or cardboard or take like an actual furnace filter, throw that up there. They'll try and put some kind of combustible material up there to catch the grease vapors. That is obviously not going to be acceptable, and we will always make the recommendation to have that removed and have it replaced by the baffle filters. The hood system, even with those filters in place, is going to have some grease vapor get through the filters, and that grease vapor, as it gets farther and farther away from the cooking equipment, is going to start to cool down. And as it cools down, it's going to start to solidify and it's going to start to coat the surfaces on the inside of that hood and duct system. So no matter how good you do with those filters, there is going to be grease vapor building up and coating the inside of that ductwork. So now if you have a fire, you have these grease-coated ducts that are going to be spreading that fire throughout the structure. So we want to make sure that those hood and those ductworks are being cleaned properly, and they should be maintained on a semi-annual basis. So we should have a professional that comes in and uses a steam cleaning system to where they're actually going to get inside of the ductwork and they're going to clean the entire ductwork from the very beginning where the grease first enters all the way to the end where it exits out of the structure. They're going to clean all those interior surfaces with that steam cleaning, and they're going to collect all of that grease that is removed from it. So that should be done on a semi-annual basis, and there should be a service tag that is mounted on the hood itself. So there should be a sticker up there that tells you when that service was done. Depending on the contractor that does it, some of them have stickers that will show you when the next one is due. Some of them will only show you when the last one was done. So you have to kind of take a look at it and read it to see what it's telling you, but it'll show you when that service was done so that you know that it needs to be done again in 6 months. What we see sometimes, though, is the insured will try to do the cleaning themselves. And so there will be no sticker on the hood because they just did the cleaning themselves. So we have no way of verifying when it was done or that it was done properly. So anytime we see that the insured is doing their own hood cleaning, we're still going to make the recommendation to have a professional come out there and do it because we have no way of verifying that it was done or how well it was done. Another tool that you can use to see that they are keeping up with their cleaning is to go to the outside and look at the exhaust outlet where the fan is blowing that grease out of the structure. Look at that fan system and see if there's a lot of grease built up on the exhaust fan itself, or if it's dripping down the walls or anything like that, or just building up in that area around where it's exiting the structure. Those are going to tell you a lot about how well they're doing with the maintenance of those hood and duct systems. Is if they are doing the proper 6-month cleanings, then you should not see a buildup on this exhaust outlet. You should not see it dripping down the walls. Again, the commercial cooking requires the baffle filters. If there's anything other than those metal baffle filters, we are going to be making a recommendation that they get them removed and replaced with those metal baffle filters. The cleaning of the hood should be done on a semi-annual basis. However, depending on the volume of cooking, you could potentially alter that cleaning frequency. Something like a McDonald's, Hardee's, or Burger King, one of those really heavy volume grease producing operations, you may actually want to bump that cleaning up and do it on a quarterly basis, just because there's so much grease vapor being shoved up into those hoods. We want to make sure that they're staying maintained. Or on the other end of that spectrum, maybe you have like a kitchen inside of like a church where they're using it maybe once a month for a banquet or something like that, where they're just not producing much grease volume at all. So then you could say maybe that you kind of drop it back to once a year they have that hood cleaning done, just because there's not much for them to clean if they're not using the kitchen hardly at all. So you can alter the cleaning frequency depending on the volume of cooking, but our standard procedure is to have semi-annual cleaning. And so, if you go into our recommendations library, the standardized recommendation is going to say that semi-annual cleaning. One thing you do want to kind of check for in the idiosyncrasies, we do have a couple of accounts that say, regardless of the volume of cooking, they want their hood cleaning done on a quarterly basis, or they may give you kind of some guidance on what they're looking for, what their personal standards are. So make sure you're paying attention to those idiosyncrasies, because they may give you some guidance as well. Then the filters, those should be cleaned on a weekly basis, but again, depending on the volume of cooking, you might alter that frequency a little bit. So something that is producing lots and lots of grease vapor, you may want to actually clean those filters on a daily basis. So at the end of every shift or every day, you go ahead and clean those off so that they're ready to go for the next day. Or if you have something that has very little cooking, maybe you only clean it, every time that you use it rather than, every week. If you're not using it every week, then there's no reason to clean the filters. So you can alter that frequency based on the volume of cooking, but our standard is going to be weekly for the cleaning of those filters. So now we want to look at the fire suppression system. So we've talked about exhausting those grease vapors out, but we also want to make sure that there's some way of, if there is a fire on the cooking equipment, how do we put that out? If you've ever seen a grease fire and you've seen somebody throw water onto a grease fire, you know that that is the last thing that we want to do. You don't want to put water onto it because it's going to then splatter and erupt, and then it's going to actually spread the fire out and make it a bigger, more violent fire. So we don't want to put water on it. So that means that we don't want to use any of those fire extinguishers that have water as their component. So, some of those ABC types of fire extinguishers where they do use water as part of their process of putting out fires, we don't want to see those inside of the commercial kitchen where they could be putting water onto a grease fire and causing it to get actually bigger and more dangerous. So we want to see the proper type of fire suppression in place. And so there's wet chemical systems and there's dry chemical systems. So a wet chemical is exactly what it sounds like. It's a liquid agent that's being sprayed down onto the fire to put the fire out. And the dry chemical then is where they're using like a powder substance. Usually the powders just drop down and it's meant to suffocate the fire, but it does nothing to reduce the surface temperature of the materials that are burning. So oftentimes it may suffocate it, but then because it didn't reduce the temperature, it's just going to flare back up. As soon as they get oxygen back into the location, it may flare back up. So it's not very effective. Whereas the wet chemical agent is designed to not only suffocate it and to extinguish that fire, but it's also going to reduce the surface temperatures, and it's going to help reduce the risk of flare-ups after the fire is put out. So that is going to be the current standard. The UL 300 listing and the NFPA 96 are going to say that you need to have that wet chemical system. There are some wet chemical systems that do not meet the standards of UL 300, but most of the wet chemicals that we see do meet that UL 300 standard. There are no dry chemical systems that will meet the standard of the UL 300. So if you see a dry chemical system, automatically that is unacceptable. We are making a recommendation to have that removed and upgraded to the UL 300 standard wet chemical system. Now, what does it mean to be UL 300 listed? Well, there's a lot of different factors and components that go into that process. It's going to be looking at the type of chemical that's being used. It's going to be looking at the number of nozzles, the spacing of the nozzles, the where the nozzles are pointed at. It's going to be looking at the sloping of the pipes going from the tank of chemicals to the nozzles. It's going to be looking at the actuation switches. So there's a lot of different things that go into making a system UL 300. To kind of simplify things, we focus in on the chemical that's being used. So we look for the AES tank that's on the wall that has all those chemicals stored in it. And we look at the tank to see if it is a UL 300 system or a chemical that they're using. So on the tank itself, there's a labeling, and down in the corner, usually there's a UL symbol. And right next to that UL symbol, it should say whether or not that is listed for UL 300 standard. But there are a lot of common manufacturers and common model numbers that we just know are going to be the UL 300. So in just a second here, I'm going to show you a list of those common ones that we do know are in fact UL 300 listed for the chemicals. Now, just because the chemical is UL 300 doesn't mean that the entire system is going to be UL 300. Again, there's a lot of different components that go into it, but we do feel pretty confident that if they at least have the right chemical in place, they're probably going to be meeting that UL 300 standard. So that's the main thing that we look at is the model number, manufacturer name and model number, so we can see if it is a UL 300 listed chemical. But as part of the process of the UL 300 standard, you do have to have a manual actuation switch. So we want some way for the employee to be able to set off the system. So rather than waiting for the fire to get big enough to set off the system on its own, if they see a fire, we want them to be able to set it off and put the fire out before it gets big. Now this switch, we don't want them to have to reach across the fire to turn on the system. That's obviously not going to be a good situation. It's not going to improve things at all. So we want to have this actuation switch located away from the probable source of fire, and ideally right next to the exit, so that we can encourage the employee to pull the switch as they're leaving the kitchen, getting out of the harm's way. So that's typically what we're looking for, is that actuation switch away from the equipment by the exit. The system does need to be serviced. So just like we see with our fire extinguishers, they need to make sure that they're coming in here, checking the pressure, checking the chemical, making sure that the chemical agents are still mixed up and activated and that they're going to work when they need it. So we need to have a professional coming in there regularly to service that system. If you don't service the system, those chemicals over time will start to settle and start to actually solidify in the bottom of those tanks. And so then when the fire is needed, it's not going to flow and it's not going to spray the way that it was designed to. So we do need to have that servicing just like we would with a fire extinguisher, but we're going to be looking for semi-annual servicing on the AES. So with a fire extinguisher, we're looking at annual service. With the AES system, we're looking for semi-annual. So every 6 months, they should be coming out and doing the servicing. Now, most of those companies will put a service tag, just like you would see on a fire extinguisher. They're going to put that service tag on the tank that has the chemicals in it, but they will also hang another one of those service tags off of that actuation switch. So you can kind of look for that service tag in either one of those places to find when that last servicing was done and who did that servicing. And then finally, we want to make sure that we have the proper fire extinguisher in place for this. So again, that ABC, that standard ABC chemical fire extinguisher that you see, that's the red fire extinguisher, a lot of times that will have some water agent in it, or whatever they're using for that A type of fire, the ordinary combustible fires, will not really react well to that grease cooking. So we want to have a system that is designed specifically for commercial cooking. So that's where we're looking for the K-class fire extinguisher, where the chemicals inside of that fire extinguisher are meant for not only flammable liquids, but flammable liquids that are heated up to a high temperature. So just like the AES system is going to do, it's not going to just suffocate the fire, it's also going to reduce the surface temperature to help prevent that flare-ups. It's also usually going to be a very similar, if not the same chemical as what you see in the AES. So it's going to work well in combination with that AES system. So you're not going to have the fire extinguisher and the AES kind of combating each other. But the two chemicals will actually work well together. So here's the list of the most common manufacturers that we see for the AES system. The single most common one that we see is going to be this one right here, the Ansel, and they typically have the R102 system. This is actually so common that it's kind of become synonymous with the AES system. So a lot of times when people refer to an AES, they will generically call it an Ansel system, even if it's a different manufacturer, just because it's so prevalent that that's become synonymous with it. So just like with Kleenex or Xerox, where the manufacturer name becomes the same as the product itself. But that is the single most common one that we see. We do see a lot of the range guards or the kitchen knights. So you will see some of these other types of systems out there, but that Ansel R102 is the single most common one that we see, and it is going to be that UL 300 compliant. When we're looking at it, one way to determine at a quick glance whether you have a wet chemical system or a dry chemical system is to look at the actual nozzles. So when you see those nozzles, a wet chemical system is going to have a really small nozzle at the end of that. So it's just going to spray that liquid out, and you'll have that real fine small tip on there, so it's going to be easy to identify. Whereas the dry chemical is going to have these much larger nozzles, more like a shower head type of nozzle, so that it can spread out that dry powder that's being released, and it's going to allow it to spread out onto the cooking equipment. So anytime we see these big nozzles like this, it's going to tell us this is a dry chemical system, and this is not going to be acceptable for our commercial kitchen. We also want to make sure that there is a nozzle devoted to every single piece of equipment in our cook line. So, if they have a piece of equipment, there should be a nozzle devoted and spraying at that piece of equipment, so that if it catches fire, there's going to be some chemical being sprayed onto that piece of equipment. If any of our pieces of equipment do not have a nozzle pointed directly at it, then that's not going to be sufficient. We're going to have them have a professional come out here and analyze the system and update it to account for all of the cooking equipment and have the proper number of nozzles and placement of those nozzles. But again, looking at the tank on the wall is going to be a great way for us to tell. Not only is going to tell us the manufacturer, it's going to tell us the model number, but then if we look for that little UL symbol down in the corner, it'll tell us right there that it meets the requirements of the standard UL 300. So we have that right there in writing that this is an adequate chemical for this current standard. The actuation switch, we want it to be located away from the probable source of fire, ideally next to the door to encourage them to leave. But this is typically going to be like a toggle or a pull ring or something where the employee can just grab it and yank on it, and it's going to set off the system. Now, we want to make sure that that is going to be in good operating control. So we want to make sure that it's set up. This one you can see they actually have some duct tape on there that's holding the system in the closed position. And that's because they've actually already set this system off. So they had a fire, they pulled the actuation switch, it set off the chemicals and put out the fire. Well, then once the fire was out, they just went and they pushed this back in the off position, but it wouldn't stay. So they took some duct tape and they taped it in the off position. So now, rather than having the professional come out and reset the entire system, they have a kind of rigged up system here where if there is another fire, one, they're going to have to hope that they still have enough chemical in there to fight the new fire. And two, they're going to have to fight through the duct tape in order to set that system off. So it's going to be a much harder process. It's going to require them to sit there for longer, exposed to the fire for longer. So this is not a good system. We want to make sure that it is properly maintained and in good working condition. So this one on the right, you can see is unimpeded. They can easily pull that little pin out and it's going to set off the system. We have the service tag on there telling us when it was done and who did it. Obviously, if we were looking at this today, it's well past due for its 6-month servicing, but at the time that the photo was taken, it was within the 6 months of that date. There's also something called the system interlock, and this is for shutting off the fuel. So if you look at the fuel line that's coming in from the outside of the building and into the pieces of equipment, you might see this little red box where it's connected to the AES system. And this little red box is going to say, okay, anytime that the AES is set off, meaning that there's a fire or there's a threat of, there's a reason that it thinks there's a fire, it's going to actually shut off the flow of gas right here at this point, so that it's not continuing to add more fuel to that fire. So this is just a way of kind of limiting and controlling that exposure by shutting off the gas away from the actual pieces of equipment anytime that the AES system is turned off. Again, for the fire extinguisher, we want to see that K class, something that is designed for grease and fats that are at a high temperature, where it's going to actually not only suffocate the fire, but reduce that temperature to hopefully reduce the amount of flare-ups after the fire is initially put out. And we want it to work well with the AES system. So it should be that K class designation. It's typically going to be a chrome color. It's usually going to be short, fat. It's usually a little bigger than your standard ABC type of fire extinguisher, but it's usually really easy to identify because it is that chrome color. It's going to have that real small liquid nozzle on the end of it, so it's not going to have the big horn like you see on some of those ABC types of extinguishers. Some of the more modern K classes will also be designated for other types of fires, so you may see more than just the K. So like, for example, this one here, you see the 2ACK. So that means that that particular fire extinguisher is designed for your ordinary combustibles, your electrical fires, and your commercial kitchens. So it was a multi-purpose type of fire extinguisher, but it does have that K designation in there, so we can allow it in the kitchen. If we don't see that K on there, then we don't want it in the kitchen. We don't want them to accidentally have that A chemical that they're spraying onto a fire and causing it to flare up and become worse. So make sure that they have the proper K class in the kitchen where it's going to be needed. They can have the ABCs outside of the kitchen, like in the dining area or the bar or wherever, but inside the kitchen, they should only have the K class. We don't want them to have both, because we don't want them the employee to have to try and guess as to which one they should be using. It should be just the first fire extinguisher that they find should be the right fire extinguisher for the kitchen fire. Now we're going to start to go looking at some of the more common recommendations that we make for commercial kitchens. This one right here is a big one. We see this all the time where they have improper spacing between the deep fat fryer and some sort of ignition source or open flame. So the left-hand side, you can see that right next to the deep fat fryer, they have that open flamed range. So there's no separation here. We need to see at least 16 inches of clearance between that deep fat fryer and that open flame. If they can't provide that 16 inches of clearance, then they need something like we see on the right-hand side here, where they have a 8-inch high stainless steel barrier separating those exposures for us here. Another common recommendation that we see is accumulation of grease on the surfaces around. So whether it's on the baffle filters themselves, or if it's on the surfaces of the hood and duct or on the walls, anytime we see that kind of grease that has solidified, it's changing colors, it's getting thicker, sometimes it gets kind of furry, or dust starts to collect in it. You see it starting to drip down, forming like kind of those stalactites. Anytime you see that, you know that this is well beyond the due date for the cleaning, and it should be rectified. They need to have those filters cleaned. They need to have the interior of the hood and duct system cleaned. But all of that grease needs to be removed from the surfaces, so it's not a potential ignition point. Sometimes what we'll see is that the restaurant owner, they will have their equipment in place. They'll have the professional come out. They'll set up the hood and duct system. They'll set up the AES system. but then maybe they change their menu, maybe they change how they're doing the cooking, they get a new piece of equipment. So now they have a reordering or arrangement is different from what the original system was designed for. So like in this photo here, you see the deep fat fryer is actually just kind of set up next to the range. So we have the clearance concern, but also the hood and duct system ends at the range. So they added this deep fat fryer later. So now there's no hood system over the top of that deep fat fryer, and there's no AES nozzle pointing at that deep fat fryer. So the biggest potential for fire is also unprotected from hood and duct system and from the AES system. So anytime there's an addition of equipment or a change of the arrangement of the equipment, we need to make sure that the hood and duct system and the AES system still cover all of that equipment. Sometimes you have light sources inside of the hook so that it's easier to see see the cooking equipment, see what they're doing, and so on. But with those light sources, we have electrical exposure. So we want to make sure that those lights are protected from the grease vapor that's coming up into the hood. So if you have a light source inside of the hood itself, it should be protected by a glass globe. That's a liquid tight globe that's going to keep the grease vapors outside of those electrical components. So we don't want anything that's going to allow for like this bulb to break and shatter into the food. We don't want any grease being able to get up into the electrical components themselves and potentially igniting. So any of these lights inside of the ductwork need to be inside of vapor-proof glass globes. And then this last one we have here, we want to make sure that the exhaust, so as it's exhausting that hot air, that steam, and those grease vapors out into the atmosphere, we want to make sure that it has the proper clearance around that exhaust fan so that it can be properly vented out. This one is not proper. You can see that it's actually kind of built into the wall here, and it's got some overhangs that are going to catch and collect that grease vapor, and it's going to cause it to build up on the underside of the structure. And you can see there's kind of discoloring the siding and causing some problems on this. So that would be an improper exhaust fan on the outside of the structure. So that brings us to the end of the presentation that we have for you today. If you have questions, make sure that you're reaching out to us and contacting us to go over those questions. We have trainers that are devoted to helping you. You can contact any of our managers here at the office or any of our quality assurance reviewers. Please reach out to us and ask us those questions. But thank you for spending the time with us today and going over commercial cooking.